So if we are going to draw the diagram for the problem, this is a hydraulic drum. And according to the problem, we have to determine the discharge in the container. The water flowing in the container. So inside the container, there is water. And what we are going to do is to determine the discharge through the orifice. So there is an orifice at the bottom. We have to determine the discharge at the orifice. Given that the diameter is 100 mm, located at the bottom of the tank, containing water at a constant depth of 1.2 meters. So the water is constant at a value of 1.2. So the height constant at 1.2 meters, and the diameter of the orifice at the bottom is 100 mm, and the coefficient of discharge is 0.6. Okay, so since the question is the discharge through the orifice, you might as well make use of the formula for the discharge, wherein we are going to use this formula for the discharge in the orifice. C times A times square root of 2GH, wherein Q is the discharge, C is the coefficient of discharge, A is the area of the orifice, G is constant at 9.81 meter per second squared, and H is the pressure head, wherein we are going to make use of the pressure head. According to the problem, the value of the pressure head, H, is constant at 1.2 meters. Plus, we are going to add the pressure head because there is an air pressure of 432 kilonewton per square meter. So if we are going to use that pressure head of the air, 432 kilonewton per square meter, you divide it by 9.81. And that would give us the value for H, which is equals to 45.24. You have 45.24 meters. And then take note that according to the problem, the value for C is 0.6. The value for diameter is 100 mm. So therefore, the area will be equals to area of a circle, which is pi d squared over 4. We're going to use that to determine the area of the orifice. So discharge will then be equals to 0.6, which is the coefficient of discharge. We multiply it by the area, pi d squared over 4, and the diameter is 100 mm. So if we are going to convert that in meter to be consistent with our unit, we're going to use 0.1 squared. Pi d squared over 4 multiplied by the square root of 2 times the value for G is constant at 9.81, and the value for H is 45.24 meters. So again, the technique is that you have to make sure that you are consistent with the unit that you are using. So based on my calculation here, the value is 0.140. Unit should be cubic meter per second. Or if you are going to multiply it by 1,000 and express the discharge in terms of liters per second, so that is equals to 140 liters per second. And that will be our answer. That is the discharge through the orifice with the diameter of 100 mm, which is located at the bottom of the tank, given all other conditions. So that's it. I am Dr. Ram again. See you on my next video tutorial.